let's start solving a transportation problem. We have a transportation problem here. There are three refinery 1, refinery 2, and refinery 3, and from refinery to distribution center. So actually they're sending oil to the distribution center. So there are three distribution centers: distribution 1, distribution 2, and distribution 3. And each refinery has a certain capacity. You see here at the right is given here. Capacity is 6, actually this is millions of gallons. So 6 millions of gallons, 5 millions of gallons, and 8 millions of gallons. And there are demand given for each of the distribution centers. So we have 4 million gallon demand for 4 million gallon demand from the distribution 1, and distribution 2 wants 8 million gallon, and distribution 3 wants 7 million gallon. Now you see the numbers written inside: 180, 180, 180, 180, and 150. These are actually distance from refinery to the distribution center. So you see here we have refinery 1 to distribution 1, 180 kilometers. Refinery 1 to distribution 2, 180 kilometers. Refinery 1 to distribution 3 is 150 kilometers. So what we have to solve here is we have to send oil from refinery, all three refinery, to the distribution center, so that we can fulfill demand of the distribution center by minimizing the distance. Actually, when we are minimizing the distance, we are minimizing the cost of transportation. So that is our purpose. Our purpose here is to minimize the distance. So let's start. We will do three methods of solving transportation problem. I should tell you that these three methods: the northwest corner, least cost method, and Vogel approximation, VAM, all three methods are actually primary solution. They provide us a primary solution or initial solution, and then we have to take extra steps. We have to do follow further methods to get the optimum solution. But for now, we are going to see how to get the initial solution. So the first step in here is to calculate, to check the raw total, the total demand and total capacity of supply. These two items are equal or not. Remember this one: if this, so we have here 4 million gallon, 8 million gallon, and 7 million gallons, and capacity here is 6 million gallon, and 5 million gallons, and 8 million gallons. We have to see this column total and row total should be equal. If it's not equal, we cannot go further, we cannot take next step. So if it's not equal, we have to take a dummy to get it equal. So let's see, are they equal or not? So say 6 plus 5, 11, and 8, 19. So we get 19 in here. And let's see the total demand: 8 plus 4, 12, plus 7, 19. Wonderful. So it's balanced. We call it balanced. So when it's balanced, we don't need to worry about that. So we will go to the next step. Now when we do northwest corner, actually it's pretty easier. We will start from the left. Well, you can follow the name. The name says it all. Northwest corner. So we'll go to the northwest corner, and we will give as much as possible to that box. So let's see how much we can give in the first one. Right, so let me make it a little smaller so that we can write in here. So I will write it in here. It's convenient for us. Okay, let me write it clear once again. Right, it's gone. Right. So I will try to solve the problem. So I will write it in the corner so that we don't have to worry about that. I will do all of them like this. So let's do it. 118 here again, and 115 here, 150, and then well, this is 900, pretty far. 900. Next one is 120 in here, so see 120. Then we have 200, and here we have 220. Okay, then we have 300 in here, and then we have 800 in here. 800. Okay, all done. Now, so check the demand and capacity when we start with the very first northwest corner. So sorry for the loud noise. For the northwest corner, we will check our the demand or column total and row total. We have to choose the smallest one. That is the highest we can provide in any box. So here we have the highest is 4 million gallon, and here is 6 million gallon. So we have to choose the smallest one, 4 million gallon. We can give 4 million gallon in here. Okay, so when we give 4 million gallon in here, that means 4 minus 4, 0. So this one is actually gone. Sorry. So I'll choose red so that we can choose this one. I can write in here. So this one is gone. Okay, now I will go back to that one and see. We gave 4 million gallon in here. So the capacity of refinery 1 is reduced to 2 million now. 2 million now. Okay. All right. Now, once this one is gone, and we can go to the next one. So next one is this one. In this box, the same. The highest is the smallest one, 8 and 2. Between 8 and 2, smallest is 2. So we can give only 2 in here. Okay. So when you give 2 in here, it becomes, this one becomes 0. So so this one is gone now. And for this one, it will be 8 minus 2 equal 6 left. Okay. Now the next one, the next box should be this one, and you see here we have 6 in demand and 5 in supply. So we can give 5. We cannot go more than 5. So 5. And when you give 5, actually 6 minus 5, we still have 1 million gallon in here, 1 million gallon demand in here. So but this one is gone because 5 is gone. Okay, now we have 2 boxes left. We have no choice right now. We have to give 1 million in here and 7. Sorry, I need to change the color. So we can give 1 million in here and 7 million gallon in here. So now you see we get 7 gone, 1 is gone in here, and 7 plus 1, 8. So all of them are gone. So now we are done here. Now we need to calculate the cost, total distance. So if you calculate total distance, you can calculate in here. So total distance is equal 4 times 180 plus 2 times 180 plus 5 times 800 plus then we have 1 times 200, 1 times 200, and plus 7 times 120. So this is our total distance. Let's calculate it first. Let me calculate. Okay, where is the calculator? sorry. So we get 4 times 180, 4 times 180 plus 2 times 180 plus 5 times 800, 5 times 800 plus 1 times 200, 1 times 200 plus 7 times 120, 7 times 120, 6,120. So the 6,120. So okay, actually this number does not make sense as long as we don't convert it into the cost per kilometer, but at least we get the idea of the value. So that is 6,120. Our purpose is to get the smallest value in here. So if you follow northwest corner method, according to northwest corner, this is the this is our answer. This is the value we get. Okay. Okay. So we have solved using northwest corner. Now let's have a look in least cost method. This is another method of finding a primary solution or initial solution. So we are still solving the same problem. So I don't have to say further, I guess, about it. So the name of this method is least cost method. Means we will choose the lowest cost of first we'll choose the route that give us the lowest cost. So have a look at the cost inside this box. Which one is lowest? You see here, lowest one in here is 120. So like last one, we will choose we will provide as much as possible in the lowest one. So as much as possible means we will check the demand or column total and row total, and we are able to take the lowest one, so the smallest one. So the smallest one here is 7, so we can provide 7 in here. When we provide 7 in here, then this becomes 7 minus 7 0, and this one become 8 minus 7 equal 1. So we still have we still have our we still have one left in the row, but the column is gone, so I cut it. Okay, and now once this column is gone, we will now choose lowest one in unused boxes. So here are the unused boxes, and you see here we have 180 is the lowest, but we have 280 in here. Which one to choose? It doesn't matter, you can choose the first one, northwest one. So how much we can give in northwest one? We have 4 in row total and 6 in column total, so we can give 4 in here. So let's give 4 in here, and then so 4 minus 4 is 0, and but we will have 6 minus 4, we still have 2 in here. Okay, let's cut this column. Second column is gone. Now we only have this column left. Now actually we have nothing much to choose in here, because the numbers are given for each. You see all 3 row total is have some values in here, so we have to give the values in here to match. So let's give 2 in here. Oh, sorry, we give 2 in here, and then we give 5 in here. We have to, because here is 5, and 1 in here. So all are gone. Now we calculate the total cost like last time, or total distance. So let's calculate total distance. Actually we are calculating distance times millions of gallons. So once again, it will make sense only if we can get the cost of per million gallons or per 1,000 gallons per kilometer. but still we get some idea from this calculation. So let's do it. 4 times 180 plus 2 times 180 plus nothing here, then 5 times 800 plus 1 times 200 plus 7 times 120. So let's get the total distance. Let me calculate it once again. Let's do it. So first is 4 times 180, 4 times 180 plus 2 times 180, 2 times 180, sorry, plus 5 times 800, 5 times 800 plus 200 plus 7 times 120, 7 times 120. It gives us 6,120, and this is actually still we are having the same value that we found in northwest corner. All right, now let's solve the same problem using a third method. This method is called Vogel approximation method, or VAM. This method is a little bit lengthy compared to the last two, but it's not that difficult. Hope you can do it easily. Let's do it. To do this one, we have to find row penalty and column penalty. I'll show you how to get this. So first, you see I added one more row and column. So the first one is, this one should be the row penalty. So I write row penalty. I'm just writing row penalty because I don't have a space in there. And here I'll write column penalty. Column penalty. Okay. So how to get row penalty and column penalty? First, look at the column. It looks spacious. It would be easier to do in here. So to get column penalty, we have to look at the values in the column, inside the column. Don't consider this highlighted one because this is our demand and supply, our demand and capacity. That's not our concern. For now, our concern is the one inside. I mean the distance from refinery to distribution center. So look at the distance, 180, 300, 220. We have to choose the lowest distance or the smallest distance. So the lowest or smallest distance in here is 180, and then we have to choose the next number, next value. So the next value after 180, the next value is 220. So what we will do, we will get the value of 220 minus 180. So once again, we have to choose the lowest value in that column, which is 180 for this case, and then we have to get the next value, which is 220 in here. Then we will get 220 minus 180, and that gives us 40. Okay. Now let's do the same way, second one. So the lowest in here is 180 and next one is 200. So the column penalty for column 2 is 20. And then the third column, 120 is the lowest and 150 is the next value. So it should be 150 minus 120, which is 30. In the same way, we will get the row penalty. So let's have a look. For row penalty, we have 150 is the lowest, and the next value is 180, so that should be 30. Then for second row, we have the lowest is 300 and the next is 800. Oh, it's pretty big, so we'll give 500 in here. Ooh, it's pretty big. Okay, And then for third row we have 120, and the next one is 200, so that should be 80 in here. Okay, let me make one in here so that you don't get confused. Okay, so now you see we got row penalty and column penalty. So we have 40, 20, 30, 35, 180. The next step is to choose the highest penalty. Be careful, again, I'm telling you again, we have to get the highest penalty. Now the highest penalty can be in column penalty or can be in row penalty. Wherever the position is, we have to get the highest value. So it's clear the highest value in here is 500. So now our target now is, because this is row penalty, so our target is row 2. Okay, now in row 2 we will choose the smallest value in that row, inside that row. So what is the smallest value inside the row? 300, 800, 900. 300 is the smallest value. Now in that 300 we will provide as much as possible. So you see our column total for demand is 4 and our capacity is 5, so we can give 4 in here. Okay, when we give 4 in here, actually our for our column 1 is gone, so we will cut this column so that we don't have to worry about it anymore. Now we will go back, and now we have to do the same process again, I mean, to get the row penalty and column penalty. Let's see they have changed or not. So the first one did not change, second one changed already. How is it changed? Because the 300 is gone now, so we have only 900 and 800, so we will get 900 minus 800, which is 100. And next one did not change. This one is no, this ones will not change because these two columns are not affected. So let's see again. Now what is the highest? Once again we have the same refinery 2 or row 2 is the highest penalty, so nothing to do, we have to choose that one now. And if we see inside this, we have 2 columns left, so 800 and 900, so we will definitely choose the smallest one. Smallest is 800, and we can give as much as possible, which is 5 and 8. Among 5 and 8, 5 is the smallest, so we can give 5 in here. So when you give 5 in here, oh, I'm sorry, I can't give 5 in here actually, because I did not do it. We have to do 5 minus 4. We have only 1 left, so actually we can give only 1 in here. So yeah, 1 and 8, we can give only 1 in here, so we can so that we don't make mistake again. I'm doing it 8 minus 1 is 7. Okay, now you see this row is also gone, so this row is gone. Now we have to calculate the row penalty and column penalty once again. Now you see here it didn't change, this one it didn't change, but this one might change. 180 and 200 did not change actually. 120 and 150, oh, third did not change at all. So now we have to find which one is lowest, highest right now, I mean the penalty. So 30, 80, 30, 8, 20. 80 is the highest penalty, so our target now is row 3. In row 3, what is the lowest number? 120. So we will try to give as much as possible in this box, and I see here refinery 3 capacity total is 8 and distribution 7, so we can give 7 in here. Sorry, so we can give 7 in here. Let's give 7 in here. So if we give 7 in here, actually it will be 8 minus 7 equals to 1. And now we can cut this one. Okay, now we have only two boxes left. You see here, two boxes left. So actually we don't have much choice in here. We have to choose 6 in this box and 1 in this box. Okay, done. Now we have to calculate total distance like last two solution. Let's do it. Total distance, actually it's not total distance, but we have to write it. Total distance is 6 times 180 plus 4 times 300 plus 1 times 800 plus 1 times 200 plus 7 times 120. Let's see what is our total distance. We have to calculate once again. So 6 times 180 plus 4 times 300 plus 1 times 800 plus 1 times 200 plus 7 times 120. So we got 4,120, which is actually way less than last two solution. So we have solved this problem using 3 initial solution methods: northwest corner, least cost method, and Vogel approximation. Vogel approximation method is giving us the lowest distance in here, but we cannot say that this is our optimum solution, but we get our initial solution for now. Thank you.